Solve for x. The quartic equation 3x to the power 4 is equal to negative 24x. Okay, so we are going to look at the solution, and most especially we want to point out wrong methods that can lead to wrong solutions. Now, there is a wrong approach to this, wherein someone trying to solve for this equation does the following errors. Now, they come here, they say 3x is common, and they divide both sides by 3x, so that x cancels there, 3 here, 1, 3 there, negative 8. 3 cancels, x here cancels, so we have x cubed is equal to negative 8. And then they proceed to find the cube root of both sides. Proceed to find the cube root of both sides, ending up with just one solution. This is incomplete. This is just one of the solutions. If you follow this method, you're going to have just one of the solutions. Remember, it's a polynomial of degree 4. We are supposed to have 4 solutions, so we don't make this error. The right method is the following. 3x to the power 4 equals negative 24x. So the first thing to do is to take this negative 24 from the right hand side, this negative 24x from the right hand side to the left hand side. So it becomes positive 24x. So we have 3x to the power 4 plus 24x is equal to 0. We have 0 on the right hand side. Now, we can go ahead and factorize out 3x since 3x is common. So we'll factorize out 3x. We're going to have 3x into x cubed plus 8 is equal to 0. Now we have the product of two expressions giving us 0. Then it therefore means either 3x, the first expression, either 3x is 0, or the second expression, which is x cubed plus 8, must be 0. Either this is 0 or that is 0. Now, 3x giving us 0, since 3 is already a constant and can never change, and 3 can never be 0, it therefore means that the element that brought the 0 should be x. So x must be 0. This is our first solution. This is our first solution of this polynomial of degree 4. So the next 3 solutions will come from this polynomial of degree 3. We have to solve the polynomial of degree 3 to have the remaining 3 solutions to complete the 4 solutions that we expect. So we have to solve this equation. So we'll now take x cubed plus 8 equals 0 to solve. Now, the way forward is to be smart enough to see that this is actually a sum of 2 cubes, because 8 is actually 2 cubed. So we'll write this as x cubed plus 2 cubed equal to 0. This is a sum of 2 cubes. So we'll proceed to use the identity of sum of 2 cubes. Look at the identity again. A cubed plus b cubed is actually identically equal to a plus b into a squared minus ab plus b squared. This is the identity that we must retain, we must use in order to solve this equation. So wherever we see a, we put x. Wherever we see b, we put 2. So we have x cubed plus 2 cubed will be identically equal to, wherever we see a, we put x. Wherever we see b, we put 2. So we have this expression. Two squared, which is simply 4. Okay, so that is it. Wherever we see a, we put x, and wherever we see b, we put 2. Okay, that is it. So this sum of two cubes using the identity of sum of two cubes is expressed as such. All right. So this is what we're going to use. All right. Now let's put it now back here. This cube plus this cube was equal to 0. So we're going to write all of this and equate this to 0. This therefore means x plus 2 into x squared minus 2x plus 4. 2 squared is 4 is equal to 0. The product of two expressions, again, giving us 0. It means either this first one is 0 or the second expression is 0. So either x plus 2 is 0. If that is true, it therefore means that when we take the positive 2 to the right-hand side, we're going to have x equals negative 2. All right, so this is our second solution. This is our first solution, second solution. Okay, so x equals negative 2 is our second solution. Now we need to get the remaining two solutions by solving this quadratic equation. So, or we now have x squared minus 2x plus 4 equals 0. This is a quadratic equation that will give us the remaining two solutions. Now, if we use the quadratic formula, then we'll say x is equal to minus b plus minus the square root b squared minus 4ac, all of this divided by 2a, where our a is the coefficient of the x squared term, which is 1. Our b is the coefficient of the x term, negative 2. Our c is a constant term. All right, so we will now put these values a, b, c, d, this a, b, c, sorry, in this quadratic equation to get the remaining two solutions. So let's continue up there. So we have the values of x will be equal to negative b, negative 2, plus minus the root of negative 2 squared minus 4ac, all of that divided by 2a. All right, this gives us negative, negative, positive, plus minus the root. Negative 2 squared is 4. All right, minus 16. 4 times 4 is 16. All of that divided by 2. So x is equal to 2 plus minus the root of negative 12. 4 minus 16 is negative 12. All over 2. Okay, so we're going to have the root of 12. Root of negative 12. Remember, that's going to be complex. Negative 12. So we're going to have will be root of negative 1, 12. And negative 1, the root of negative 1 is I times root of 12. So have I into 4. 12 is the same as 4 times 3. So it will be I into root 4 times root 3. So it will be root 4 is 2. So we're going to have 2 root 3i. Okay? 2 root 3i. All right, so we'll just come and put it here. So this will give us 2 plus minus 2 root 3i all over 2. All over 2. All right. See, we have 2 is common there. So 2 can go, 2 can divide with all the members of this expression. So 2 here 1, 2 there 1, 2 there 1. So end up with 1 plus minus root 3i. Okay. So this gives us the remaining two solutions. So finally we have values of x. Values of x. Finally we have values of x will be, the four values will be x equals 0, x equals -2, x equals 1 plus root 3i, and x equals 1 minus root 3i. So we now obtain all the four solutions of that quartic equation, or that polynomial of degree 4.